So this part, 7.4 was based on proportions. And the only difference with the proportion is your numbers are discrete numbers. You can only have a whole number of people saying yes to something. You're going to find there's no mean, there's nothing that I need to, no standard deviation in here. So this is the proportion one. I need to make sure that I get my sample, I get my p-hat from my sample. If you're using your calculator, we talked about this in class. P-hat is x over n, part over whole. So if they told me that my p-hat is 10%, 0.10, and my n is 200, to get an x, I'm going to multiply these two together. If they told me that my p-hat is 10% with a percent sign, I have to move my decimal over before I can multiply this. This is what I'm going to have to put in my x for my calculator. So this is my 20 people here. And I'm going to, if you're using your calculator, your x has to be a positive whole number. It cannot be a decimal. If you multiply this, and I saw this yesterday, it was a little disturbing. Somebody multiplied 10 times 200 and got 2,000 and put 2,000 in here. And 2,000 says, how can you possibly get 2,000 out of 200? So make this make sense. Common sense on this. P-hat is all from your sample. Sometimes they say 10 people out of 200. Sometimes they say 53 people out of 976 people. And you have to find your p-hat. Sometimes they give you the percent. And if you use your calculator, you have to find your x. If you don't use your calculator, you use your formulas, you don't need x. Because your formula uses p-hat. We talked about the test in the beginning, before you even go to do any work. This is to tell us, does it approximate a normal curve? Normally we say with the z-scores, is n greater than or equal to 30, or did they tell us it approximated a normal curve? This one, it's a discrete binomial, it's a discrete situation, a discrete probability. They expect us to test it. Now, when we go over the ones in class, and I kind of just say, okay, we know the test works, the test has to work, because otherwise, otherwise we'd have no problem to do. So these three individual ones, they asked you to test. If it does not approximate a normal curve, you stop right there. So on this guy, does not approximate a normal curve. We stop right there. Okay? The second one, we test n times p, n times q. Remember, test the smaller of the two. If the smaller one works, the larger one has to work. If the smaller one fails, who cares what happens to the larger one? You cannot use this. So always test the smaller one. I would just run my test on this guy, the smaller one. And this one passes the test. So therefore, then they said, make your decision based on your information. It didn't tell you if you needed a p-val or a reject region. You could use either one. What they did have is they gave you your claim, no words. They just showed you where it was. That's your Q. If you want to find your reject region, your z-score for that, inverse norm, and your level of significance is 0.04. And again, I say this all the time, God bless you. Since the very beginning, I said, the right-hand side is positive, and the left-hand side is negative. And everybody laughs, yeah, we know that part. I cannot tell you how many kids still give me the negative on the right-hand side. If you look that up, it gives you a negative. You use the positive. Okay? Then when you find your z-test, it came over here somewhere. And we say fail to reject. It's in your fail to reject H0. Every once in a while the book does that. I don't know if they make a mistake and they have the wrong tail there, or they meant to do that. I would have thought they would have meant to have it as a less than, because you'd get the same cutoff over there, and it would at least be in the same area. But it's very possible that it is that far off as well. In real life, or whatever, but if you're doing this testing, and you came out with it completely on the opposite side, you might say, I might want to do another sample for this, because maybe my sample isn't a good representation of my population. Maybe I'll sample again. So are we okay with this? P-val, same thing. Yes. I'm getting to number 8. Yeah. Yeah, I'm getting there. Okay. Number 8, we had a test first. So, when we take this and we do n times 3 and n times q, p is 0.95, q is 1 minus 0.95, which gives us 0.05, not 0.5. When I test 0.05, it fails the test. So there's nothing we can do with the 8. We just say, cannot use this, it does not approximate a normal distribution. Sorry, it has to pass both. That's why I keep saying, always do the small one. Whichever one is the smaller one of the percentages, do the small one. If the small one fails, no need to go any further. If the small one passes, no need to go any further either. You're good to go. Okay? Okay, so now, we get to the word problems. A medical researcher says less than 25% of U.S. adults are smokers. Flip to the last sentence. Is there enough evidence to support the researcher's claim? So, is he my researcher? Yes. So when he says this, this is his claim. So we claim that. Is it the mean that's less than 25%? What does percent start with? P. P. Percent proportion. I want a P, not a mu, not an X bar. Make sure I get a P. P is less than 25%. If you put 25% in here, that's fine, but when you go to use this, it's got to say 0.25. So put the decimal in from the very beginning. It has no equal sign. This is my HA. I follow this tail. It points to the left. I have a left tail test. HO is the complement. In this case, greater than or equal to. You with me, Jared? Oh, you're in your calculator. Okay. All right. Sorry about that. I saw you punching away there, and I'm like, So, when you get this done, and did they say this one had to be done with a reject or a p-val? Did it say? Okay, so either one you use for this, we'll use both for this. I guess they use the reject region. So you need to find this cutoff. This is a z-score we're doing with your proportions. So your inverse norm, 0.05. Don't subtract it from 1. Don't divide it in half unless it's a 2-tailed. And if it's negative, on the left-hand side it's negative, on the right-hand side you make it positive. Label your reject HO, make sure you say HO, fail to reject HO. This is your test statistic. I'll give you this formula. Plug in your pieces, be careful which way you plug it in. When you get to here, your P, your Q, it comes from your claim. So your Q is 1 minus your P. And then see where this falls. Does this fall in here? And so your decision is reject H0. Since your claim, and make sense out of this. If you reject this guy, are you going to be able to support your claim? If you don't want that one, you want the other one, right? Yeah. So essentially, you're going to be able to support your claim. You want to put your phone away? I'm going to start taking phones away. While we're working, I don't want to see phones out. So there's enough evidence, and you just have to fill in some of the pieces. At a level of significance of 0.05 to support the claim that less than 25% of U.S. adults are smokers. Questions? This is a very good time to ask me a question. If you use your calculator, here's a little bit of a problem. Your p-hat is 19.3%. Your n is 200. Your calculator needs an x. So how do I find the x to put this in my calculator? 0.193 times 200. And what happens if I get a decimal? Round up or down. Use your rules of rounding. You cannot put a partial person in there.
Would you always round up or not?
Typically, if you need 19.3%, you should be rounding up, but if you use your rules of rounding, I'm fine. Like, I need to reach that number to know that, but if you leave it to me with rules of rounding, I'm good. So what did your X happen to be, those of you that did this?
39.
39. I need this to put it in my calculator. Do not put a decimal in there. Some of you are getting domain error. Domain is what value, your X or your Y? Your X. So the first thing you had to look, and you've been doing domains for 3 years. Algebra 1, geometry, trig. Everybody uses domain, pre-calc. So domain is the X. Look at your X value. Don't call me over and say it says domain error. Look at it. Make sense out of it. Question, Chick.
So can you only find your X and then using a calculator, or you have to use a calculator on X and Y?
Well, it depends. Did you use your calculator step to solve this? You used your equation. You don't need your X. You only need your X to put in your calculator. Third question?
So because we had to round up for X, does that make the Z-score different on the calculator?
If you rounded differently, so that's why I need you to tell me what you did. I need to see what you did. So then I'll put yours in.
So like the Z-score that we had on the calculator is different than what I know.
Right.
It's still rejected.
But it's still
Right.
rejected.
Well, I use this formula. You use the calculator, so you have a rounding issue in here. Yeah, but but that's why you tell me calculator. So, and I'll know. So when you come here to one proportion, it says P sub 0. This is from your population. Almost says POP, population. Think of it that way. PO, population. I put in my 0.25. The calculator is a great tool. It just needs that X value. And then we come here, we follow the tail of your HA, wherever it's pointing to, and you calculate. There's your Z-score, negative 1.80. That's your test statistic instead of this one, because we rounded on your X value. Because look at your p-hat now. It's a little bit different than 193. We had to round. And I get that part. Here's your p-value if you want to test p-value. I could look negative 1.86 up in my table 4, and I could find my p-value. It's to the left. I look up negative 1.86, and I get my value. It's very close to 0.0362. If I want to, I can test my p-value. It's close to that. I don't know what it exactly is. P-value against my level of significance. Fill it in. This is less than...
It's 360.
Oh, 360. So less than or equal to, thank you, dyslexic math teacher. Less than or equal to, I have to get the same exact decision on this. And if it doesn't say, you can test whatever you're comfortable with. We're good? Okay. Speak up, because I was hoping with you doing this in class, and you guys did, a lot of you called me over. I was kind of hoping to fine-tune maybe the parts that you just weren't connecting with. Because once this clicks, you will say to yourself, this is so simple. It's just, I might change the P, the U, I might change the parameter, but the process doesn't change. So here's a research center claims that at least 46% of U.S. adults think that the IRS is not aggressive enough in pursuing people who cheat on their taxes. Flip to that last sentence. Is there enough evidence to reject the center's claim? Oh, this is my center, this is my claim, and reject means, is my claim going to be HO or HA? HO. So does it have to have an equal sign or no equal sign? Equal sign. There it is. At least. Greater than or equal to. So this all ties in. It's almost like a little checks and balances here. So we go to this. We say greater than or equal to. We say that's our HO, that's our claim. We follow the tail of the HA, so we have to find the HA first and then do your tail. Your cutoff value, again, inverse normed, 0.01. I want to know if this area is 0.01 in here, what's the Z-score associated with that area? Okay? So I find my z-score. I don't care if you use your calculator, whatever you use. Our sample information gave us our p-hat. I like to write my information down, and you know where it helps me? If you write your information down, I can tell what you used and what you didn't use. A lot of you, not a lot of you, there are some that as you're putting in the numbers and you get to n, I don't know where your n comes from. You got a different n in there. Maybe it was the n from the previous problem, but you give me a different n. But if I know that you had n, usually I just circle it, and I just take off a point or a half a point rather than take off the whole thing. So I try to give you as much leeway on this as possible. Again, find your Q for this guy, 1 minus this. That goes in here. And it kind of doesn't make as much sense to use your P and your Q from your population, but your N from your sample. But that's the way the formula is. I would have thought if I'm using my N, I would use my P hat and my Q hat. It would almost like fall into place. But the formula says P and Q. So we do what the formula says. Kind of like when they do the population over the square root of n. Population and square root of n kind of don't work together either, but that's what we do. So we turn out that we reject this guy, reject H0. So think of it logically. If you don't take this, then you agree with this. But we're going to have to say there's not enough evidence, or there's enough evidence to reject the claim, put your level of significance in, that at least 46% of the people think the IRS is too lenient. You can sum it up a little bit, or you can rewrite the whole thing. Question? Everybody's able to do this. Okay. Number 12. A medical researcher claims that 5% of children under 18 years of age have asthma. This is his claim. So I flip to the bottom, to the last sentence. Is there enough evidence to reject the researcher's claim? So yeah, that's my claim, and reject tells me HO or HA. HO has an equal sign, so my claim should have an equal sign. And that's a good help for me here, because sometimes kids have trouble with one that says equal, because there's nowhere that says, oh, this is equal to. If that's their claim, this is their statement they're making, that's the equal. So P, it's a percent, proportion, equal 0.05, there's your claim. So your HA is your two-tailed test. Now your two-tailed test is the only thing that's a little bit different. My level of significance says this piece and this piece add up to 0.05. Therefore, if I'm going to look up this one side only, I need to do an inverse norm and split this guy and only look up this half of him. It tells me this plus this is 0.05. It gives me my reject region. It gives me this cutoff value. The book calls it as Z sub 0, and I call it a Z sub C. Critical value, it's a critical value, it's a cutoff, so I find that C works out better when I explain it that way, because it's cutoff, critical, they both begin with C. Z sub 0 is like an initial type thing. It's really not an initial value, it's really a critical value. So I use these. Different books use different things. I think I was just taught with Z sub C, so that's what I use. So you do your inverse norm, and the negative goes on the left, the positive goes on the right. Your graph, again, is symmetric. So you pull up your information. This has to get sent to a decimal. This is 9.6%. Move it 2 places. 0.096. Okay, and again, well, we didn't test these, but we would have had to test each one of these for n times p is greater than or equal to 5, n times q is greater than or equal to 5. We didn't test them, but we should have. But I know they work, otherwise we wouldn't have a problem to do. So we find that it falls in your reject H0 section over here. Now, if you want to do your p-val with this, when you look this up, you're going to look up, since it's on the right-hand side, you're going to look up your area to the right of this, which is really, really close to 0, isn't it? What's the last one on your chart? 0.4, 4.2 or something like that, 3.4. So it's really close to 0, but the only thing you're going to have to do when you find this value is if you look it up on the positive side, you're going to subtract it from 1. If you look it up on the negative side, you're fine. But what do we have to do when we find the value? Because it's 2 tails. Multiply it by 2. We do half to find your inverse norm. Anybody have a table 4 available? Can somebody look up negative 3.34 for me, please? Thank you. So that's this little area right here. This is where my 3.34 is. So because I have 2 tails, I get to multiply this by 2 if you're going to do a p-val test. P-value with 2 tails. So 0.0008. Compare this to your level of significance. You're still going to get the same exact answer, but you're going to see again how small that is. If you put this in your calculator, let's just drill this guy in your calculator. You're going to see with your calculator, the nice part about this with your calculator is that it does the 2 tails for you. It multiplies it by 2. So here is your 0.096. Your x. We have to multiply that by 250, and we get 24. 250. 2 tail test. Here's your p-val. Here's your p-val over here. Why did it come out so high? What did I do wrong? Oh, 96, 24.
It's not 096. 0.05.
Oh, 0.05. Thank you. 0.05. Hopefully that will make a difference. There it goes. Now, I want y'all to look at this. There's my z-score. There's my p-val. So what is my p-val according to this? What is it? 0.0008. Could I possibly have an area greater than 1? The whole curve is equal to 1. So can my area possibly be 8.4? No. What does this e to the negative 4 do? Move the decimal 4 positions to the left. So when you get here, don't just write down that number. Your area can never be greater than 1. So there's my p-hat, my 0.096. Yep, I have that. There's my z-score. I got that. And my p-val, I just got to move my decimal. It already multiplied it by 2 is my point as well. Okay? Number 15, a humane society claims that less than 35% of U.S. households own a dog. Flip to the last sentence. Is there enough evidence to support the society's claim? Now, we saw a couple that the sample came first and then came your claim. So always look at that last sentence. It will help direct you to where your claim is. Sometimes it doesn't always use the word support or reject, but we'll get close enough to it. So I've got an HA because I use the word support, and it says less than, perfect. My P is less than 0.35. There's my claim. My HO is P is greater than 0.35, greater than or equal to 0.35. Okay. Find your cutoff value. Your tail is the left tail test. Find your cutoff value, inverse norm. If you do that, you can deal with your p-val. You can take this guy, look it up in your calculator or your table, either one. Your area to the left, because you're a left tail test. And your p-val you would see is a lot more. And we can tell by the graph. Isn't your p-val going to be a lot greater than your level of significance, because this tells me all of this is to the left of this guy. So of course there your p-value is far greater than 0.05, 0.10. So you fail to reject H0. When you fail to reject H0, you have to keep this. You cannot support this claim. So that'll kind of help you realize that it's all falling into place when you look at your chart. So there's not enough evidence at the level of significance of 0.10 to support the claim that less than 35% of homeowners own a dog. We good? Okay. The last one? This is your last one. So you interview a random sample of 50 adults. This time the sample came first. The results of that survey show that 48% of adults said they were more likely to buy a product when there are free samples. Now, that's what we're given so far. At a level of significance of 0.05, can you reject the claim that, here's my claim. This is my claim. This whole thing was from my sample. They said the results of this survey from your interview, that's my sample information. Here's my claim. Can you reject the claim that at least greater than or equal to 52% of adults are more likely to buy a product when there are free samples? You know, when you go to the grocery store and they hand out all these little free samples of things to eat, you say, oh, this tastes so good. Let's go home and make this. No. So you buy all those things because you tasted them. Okay, so we're testing that claim. And it uses the word reject. So we're looking at the reject word in here. So it's got to have an equal sign in your, it's got to be an HO. So we're good with that. We find your p-val, 48%, okay, and we test. And we find your z-score, your test. This is called the test statistic. Because this is coming from my sample. This is what I am testing to challenge the population. Okay. You can get your area if you want. Use your test, your proportion test in your calculator. Yes.
I think what it says he had equals 0.38. Will you keep that?
If I say he had, yeah, because if you're going to use your calculator, you don't need it if you're using the formula. But if you use your calculator, you have to say 48.48 times 50. That gives you 24. You have to use the x for your calculator, but you know, use the p-hat in your equation. So again, any questions on this?